Welcome to Alpha Centauri Part 2. Today we will be working on the preliminary math to figure out what our target velocity will be, how fast we can accelerate, and also look at the first means of acceleration. So, to start off, there will be a few equations that are a little bit more advanced than just dividing stuff. And the first one we will need to know is force equals mass times acceleration. So that one will be used to figure out our mass acceleration. And then we also need to know the equation for momentum. So momentum is equal to mass times velocity. Then the final equation we'll be using today is force times time is equal to mass times velocity. So that is the equation for impulse. So now that we've got our basic equations packed away, let's go ahead and look into how much we can accelerate and other parts of the project. Okay, so the first thing we need to figure out is our mass acceleration. So to do this, we will be using the equation force equals mass times acceleration. So we'll plug in our knowns. So the first part of your body that will break or no longer function at a certain velocity is your heart. So we know the mass of the average human heart is 0.4, and we know how much force it takes to break a human heart, which is 102 newtons. So after 102 newtons, your heart will pretty much rupture and you will die. So that is not good for our astronauts. So we want to figure out how fast we can go. So then we have our acceleration. So we need to get our variable on its own. So we can move the 0.4 over by dividing it by 0.4. So it would be 102 divided by 0.4 is equal to the mass acceleration. So 102 divided by 0.4 is 255, but that is the point where our astronauts' hearts would break. So we're gonna go down a little bit and our mass acceleration will be 200. So that will be our variable that pretty much tells us how fast we can accelerate. So I'll see you in the next to figure out how much momentum we have and a lot of other. Okay, so now we're gonna look at our momentum and one other variable. So for our total momentum, which is how much force we're going to have to apply to the rocket, which we'll see later when we bring in impulse, will be our mass, which is undefined because we will change this throughout our different tests, so to speak, and we'll change it a lot to see what works best and what doesn't. And then we've got that multiplied by the speed of light times 1,000 to make it into meters per second, and then we multiply it by our target speed, which will be a fraction, so like 1/5, 1/20th maybe, and that's just how fast we want to go compared to the speed of light. And then that will equal our total momentum, which is how much force we'll have to apply, and we'll see more about that in a second. And then we have this, which is our equation for how long it's going to take us to get up to target velocity. So we have 300,000 again, we have 1,000, and then we have our target speed fraction, and this will show how much, and then we divide it by our max acceleration to get how much time it's going to take to get up to that speed, and that will have to be doubled in the end because we have to speed up and slow down, and that'll be showed more in depth in the next clip. So this is what our trip will look like to Alpha Centauri. So this is just a quick diagram. We have Earth here, Alpha Centauri here. This is T from the last clip. It is the acceleration time it'll take to get up to target speed, and we also have to slow down to land perfectly at Alpha Centauri. And then we have V, which is us going at our target velocity the entire time. So pretty much this is what the time it takes to get to Alpha Centauri will look like. And this could change. These could be longer or shorter depending on how our acceleration looks and what our target speed is. So on to the next clip. Okay, so now we're going to look at our first form of propulsion, which is rockets. So how many rockets would we need? Well, we know our momentum that we would have to get up to be traveling our speed, and we know how much force it would take to get up to that speed, which is our momentum. So we have our output of the rockets per second in newtons, times it by the speed, that's impulse, force times time, this is in minutes. So what we would do is have it multiplied all together, divided by momentum, and then we have to multiply it by 2, the entire thing, because you have to slow down and speed up. So that would be how many boosters it would take to get to Alpha Centauri. So to find how much it would cost, all you need to know is how much the actual rocket costs and how much fuel you need and how much the fuel costs, and you can all calculate it, and that all depends on what time it is and what kind of fuel you're using in your rocket. So I'm just going to plug that in at the end, and instead of calculating it on screen. So now we have one last piece, which is total time, and all total time is displacement over max velocity, and divide all that by 31,536,000 to get how many years it would take to get to Alpha Centauri, which is a long way away, so it's going to be a very large number. So I want to thank you guys for watching this video. Hope to see you in the next one. Make sure to leave a like down below, and if you're not already subscribed, go ahead and subscribe. There will be more of this coming in the future. And thanks for watching, guys.